Crystallography, the branch of science that deals with the study of structure, geometry, and properties of crystals, is called crystallography. 1. Symmetry in crystal. A crystal possesses following 3 types of symmetry. Plane of symmetry. It is an imaginary plane which passes through the center of a crystal can, divides it into 2 equal portions, which are exactly the mirror images of each other. Axis of symmetry. An axis of symmetry or axis of rotation is an imaginary line passing through the crystal such that, when that crystal is rotated about this line, it presents the same appearance more than once, in one complete revolution, i.e., in a rotation through 360. Suppose the same appearance of crystal is repeated on rotating it through an angle of 360 n around an imaginary axis. Is called an n-fold axis, where n is known as order of axis. By order is meant the value of n into pi, so that rotation through to pi n gives an equivalent configuration. Center of symmetry. It is an imaginary point in the crystal that any line drawn through it intersects the surface of the crystal at equal distance on either side. Only simple cubic system have 1 center of symmetry. Other system do not have center of symmetry. The total number of planes, axes, and center of symmetries possessed by a crystal is termed as elements of symmetry. A cubic crystal possesses total 23 elements of symmetry. 2 laws of crystallography. Crystallography is based on 3 fundamental laws. Law of constancy of interfacial angles. This law states that angle between adjacent correspond faces is interfacial. Angles of the crystal of a particular substance is always constant. In spite of different shapes and sizes and modi of growth of crystal, the size and shape of crystal depend upon the conditions of crystallization. This law is also known as Steno's law, law of rational indices. This law states that the ratio of intercepts of different faces of a crystal with the 3 axes are constant and can be expressed by rational numbers. That the intercepts of any face of a crystal along the crystallographic axes are either equal to unit intercepts, i.e., intercepts made by unit cell A, B, C, or some simple whole number multiples of them, e.g. Na, NB, NC, where n, and n are simple whole numbers. The whole numbers n, and n are Collidweis indices. This law was given by Hauy, law of constancy of symmetry. According to this law, all crystals of a substance have the same elements of symmetry. Is plane of symmetry, axis of symmetry, and center of symmetry. In this lecture, we have covered the whole concept of crystallography. In the next lecture, we'll talk about asterisk, space lattices, and unit cell asterisk. Thank you. Subscribe Skoda Prep for this amazing lecture.